pause a few times during the video just to kind of help reinforce some things. I'm going to turn back on the back lights so you can write stuff down.
Different ways of sending information,
And you
either
can't
by
see
analog
it.
or by digital.
Try that again. There we go. All right.
Analog and digital signals. There are two different ways of sending information, either by analog or by digital signals. So what's the difference? Well, let's look at the analog signal on screen. We can see that it varies continuously in both amplitude and frequency. And the signal.
So I'm going to pause. So he said analog signals vary in amplitude, which just means how tall they are, and frequency, which means how close they are. So those are two things that change with our analog signals. So if something gets distorted, it can get taller or shorter, or it can get farther apart and closer together. Now, if we're talking about sound, if amplitude gets changed, then the sound becomes louder. If the frequency or how close it is gets changed or distorted, that changes the pitch. So if you imagine listening to something and the loudness can change and the pitch or the tone that gets made changes, you can imagine how difficult it might become to be able to understand what's being said or whatever sound is being produced. So those are two things that get changed with analog signals, both height and width, which if we're dealing with light, changing amplitude changes brightness, and changing the frequency or how close it is changes color. So that if it's a visual thing, it's being transmitted analog, that could change a lot of what you're seeing if the colors and brightness are being distorted.
Signal can take one of many different values. Now let's look at a digital signal. So here we see that the signal can only take two values, either a 1 or a 0, which we sometimes call on or off. Digital signals are sent as a series of pulses of either 1s or 0s. Okay, so that's great, but which is better?
So I'm going to pause, go back to that, and just relook at that signal. So with our digital, there's either just a complete up or a complete down. And the only thing that kind of changes here, this would be more zeros strung together. This would be less ones strung together. So it's just really how many ones or zeros next to each other is really the only thing there might be a little distortion in. But it's either something or nothing. So there's fewer areas for distortion to affect the signal. So he's about ready to make a claim, which you can make all the claims you want, but if you don't have evidence and reasoning to back it up, it doesn't do us any good. So I want you to look at what he models and why he feels the way that he does. And it might give you some information that might help you in making your own claim.
Great, but which is better? Well, digital is a much better way of sending information over long distances. Now let's see why. So, here is someone talking on a phone. The signal from their voice is analog sound, and it enters the phone and is converted to a digital signal, and then sent out via microwaves to a phone mast, which then sends it on to a satellite, and then back down to another phone mast, and then on to the person receiving the phone call. Let's look at the signal received by that phone. If we look, we can see it has picked up a lot of noise or interference. But it's still really obvious exactly what it should look like, so the phone can easily convert it back perfectly to be the same as the original signal. Now,
All right, so I want to kind of reinforce what he just showed us. So even if some distortions show up in the digital, is it clear whether it's a 1 or a 0, even with all those variations? That's why this is easier to transmit, because it's just pulses of information rather than continuous tons and tons of information. And it's more accurate, because even if there is distortions or whatever you want to call it that can show up, since it's just a all or nothing value, it's clear whether that was supposed to be nothing or clear whether it was supposed to be something. And that's why, so it's the structure of all or nothing that allows it to be more accurate. And that kind of ties to our reliability and that structure piece. Another thing I want to briefly address is, can signals be converted back and forth between analog and digital? Yeah, and that's kind of what it showed. When we speak, the sound we're creating is an analog signal. But when we're using a cell phone, the cell phone converts it to, rather than the actual sounds, a pattern of ones and zeros. So certain patterns of ones and zeros get the loudness, certain patterns get the pitches. So there's just a whole bunch of ones and zeros that get sent or transmitted by the phone and bounced from tower to tower and received by the next cell phone. And so even if there's those distortions, when the cell phone receives it, it still knows what to convert it back to in that pattern of sound to create and turns it back to that analog when it comes from your phone to your ear to be able to hear. So yes, things can be converted back and forth between analog and digital, but the more steps for conversion, the more likely analog signals will be distorted and become more difficult to interpret accurately, where the more digital ones, there's less opportunities for those distortions to affect the information.
Now let's look at this using analog. So now the analog signal, sound, enters the phone and is turned into an analog electrical signal and sent down copper wires. Now, note how it picks up noise and interference, and the amplitude is reduced as it travels until it gets to the other phone. Now let's look at it again.
So I'm going to pause it there, and hopefully that'll come back. There we go. So if we're looking at this analog signal, and how tall it is how loud. When we start adding all of these kind of like scratchy marks, does that affect the loudness of it? And that would affect how we're able to hear something if that's a sound wave. And if that, the up and downs changing affects brightness, if we're talking about light. If brightness changes when you're trying to look at something visually, that's going to affect what you're able to see. And then if the closeness gets affected, then that's our tones and those pitches that affect trying to understand what you're hearing, because tones and pitches make a huge difference on that. So it's these distortions that, because there is so much continuous and varying information, those distortions get stuck in that and continue to be transmitted, where in digital they can be filtered out because there's only, a few options of up or down, rather than somewhere in the middle. Which one is it supposed to be? Kind of hard to determine.
It looks very, very different to the original signal now. It's almost completely impossible to know what this signal should have looked like. And it needs amplifying as well. This amplification is only going to amplify the noise just as much as it does the signal. So noise or interference has really damaged the analog signal. And this is why digital is so much better than analog. Noise or interference is just not a problem for digital, but is a huge one for analog, making digital signals much higher quality. Other benefits of digital are that it can carry much more information. In fact, you can send multiple different signals all at the same time. And digital signals are also easily interpreted by computers.
All right. So hopefully some of what he showed helped some of this make a little bit more sense on why it's easier to transmit, because if it's only pieces of information, there's less to transmit. And he also mentioned that a benefit is more types of things can be sent, but that's because there's less information, so it can kind of layer pieces when it's being transmitted. But since this is getting every single fractional amount, there's a lot more information that has to get sent, but that information can easily get distorted. So what I want us to do now, I'm going to have you write down a couple definitions, and then we're going to kind of look at some examples to make sure we know what these definitions mean. So I want you to write down the definitions you see on the board for analog and for digital.